Shirlyn H. Raro. For this time, I'm your tutor in analytic geometry about the distance between 2 points. We all know that the distance between 2 points are the length of a line segment connecting them. Can be determined when we know that the coordinates of the endpoints. If a line is drawn, point 1 parallel to the x-axis and point 2 parallel to the y-axis, these two lines will intersect q quantities of x sub 2 minus y sub 1 and thus forming a right triangle. Point 1, q and q point 2. So now let us apply the Pythagorean theorem to angle point 1, q point 2. We have absolute value of point 1 and point 2 squared equals distance between absolute value of point 1 q plus distance absolute value of q point 2 squared. But the distance between point 1 q is equal to x sub 2 minus x sub 1 and distance between q point 2 is equal to y sub 2 and y sub 1. Substituting this into equation 1, we have absolute value of point 1 and point 2 cube equals to absolute value of x sub 2 minus x sub 1 and absolute value of y sub 2 and y sub 1 cube, or absolute value of point 1 and point 2 equals square root of absolute value of x sub 2 minus x sub 1 plus absolute value of y sub 2 minus y sub 1 is customarily written in the form of absolute distance of absolute value of point 1 and point 2 equals square root of the quantity of x squared minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Since the absolute value of x sub 2 minus x sub 1 squared is equal to the quantity of x sub 2 minus x sub 1 squared and the absolute value of y sub 2 and y sub 1 squared is equal to the quantity of y sub 2 minus y sub 1 squared, because it defines the undirected distance between 2 points, point 1 and point 2 in the plane. It is also denote the length of the line segment point 1 and point 2. In using the distance formula, it's make no difference which of the two given points is denoted by point 1 and which is denoted by point 2. So now, let's have an example. So now, let's solve this example number 1. Find the distance between point 1, the quantity of negative 2 and positive 2, and point 2, the quantity of negative 2 and negative 3. First step is to graph the problem. So I had already prepared a Cartesian plane here. The point 1 is located to second quadrant because it is negative and positive. So we count negative 2 from the x-axis. 1, 2 here. And the positive 2 from the y-axis. 1, 2. So this is the point 1. And the point 2 is located to the third quadrant because it is both negative. Negative 2 we count from the x-axis. 1, 2. And negative 3 from the y-axis. 1, 2, 3. So here is B are both in the second quadrant because it is negative and positive. So now, first step in the problem. The point A, negative 2, we count from the x-axis. Negative 2, 1, 2, here. And positive 1 from the y-axis, 1. So here is the point A. And the point B, negative 5 and positive 5. X-axis is negative 5. 1, 2, 3, 4, 5. And 5, positive 5, count from the y-axis. 1, 2, 3, 4, 5. So here is the point B. So now we can trace the point to locate the distance. So here. Okay. After we plot, we can now solve. So now we can solve it using this formula. The distance between A and B equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So the x sub 2 and minus x sub 1 is negative 5 minus negative 2. And the y sub 2 minus y sub 1 is 5 minus 1. So negative 5 minus negative 2 here. And 5 minus 1 is equal to 4. And when the sign is the same, we change it from negative to positive. So this is the changes. From negative 5 to minus negative 2, we change it to positive negative 5 plus positive 2 squared minus 4 squared. So negative 5 plus positive 2 equals negative 3. 4 times 4, 16. Negative 3 times negative 3, 9. And we copy 16 to this. And 9 plus 16 equals 25. So the square root of 25 is 5. The distance between A and B is 5. So again, I'm Shirlyn Raro, your tutor for this day. Thank you for watching. Bye-bye.